Similar triangles. Pythagoras was an a Greek philosopher, mathematician, and founder of the religious movement called Pythagoreanism. Pythagoras made influential contributions to philosophy and religious teaching in the late 6th century BC. He is often re- revered as a great mathematician, mystic, and scientist, but he is best known for the Pythagorean theorem which bears his name. From these learning outcomes of this chapter, similar figures, similar polygons, regular polygons, scale factor, similar of triangles, basic proportionality theorem, that is Thales theorem, converse of Thales theorem, dividing a line segment in the given ratio, criteria for similarity of triangles, angle, and side, and side angle, side. Areas of similar triangles, Pythagoras theorem, Bodian theorem is called Bodian theorem, statement, negation, converse, proof by contradiction. The geometrical figures which have the same shape with all parts in proportion are called similar figures. The heights and distances of distant objects can be found using the principles of similar figures. Two polygons with same number of sides are said to be similar if their corresponding angles are equal and their corresponding sides are in proportion. A polygon in which all sides and all its angles are equal is called a regular polygon. Here look: square, equilateral triangle, and regular pentagon, regular hexagon. The ratio of the corresponding sides is refers to as a scale factor or representative factor. All squares are similar. All circles are similar. All equilateral triangles are similar. All regular polygons of the same number of sides, such as equilateral triangles, squares, etc., are similar. Two congruent figures are similar, but two similar figures need not be congruent. A square ABCD and a rectangular PQRS are of equal corresponding angles, but their corresponding sides are not in proportion. The square ABCD and the rectangle PQRS are not similar. The corresponding sides of a square ABCD and a rhombus PQRS are equal, but their corresponding angles are not equal, so they are not similar. If a line is drawn parallel to one side of the triangle intersecting the other two sides at two distinct points, then the other sides are divided in the same ratio. In triangle ABC, D is parallel to BC, D is parallel to BC, and then AD by TB is equal to AE by EC. This is called basic proportionality theorem or Thales theorem. If a line divides any two sides of a triangle in the same ratio, then the line must be parallel to the third side. In triangle ABC, a line L intersecting AB in D and AC in E such that AD by DB equal to AE by EC, then L is parallel to BC. This is converse of Thales theorem. Two triangles are similar if their corresponding angles are equal, their corresponding sides are in the same ratio. If in two triangles corresponding angles are equal, then their corresponding sides are in the same ratio or proportional, and hence the two triangles are similar. For example, let in a triangle ABC and DEF, these two are triangles where angle A equal to angle D, the corresponding angles equal, angle B is equal to angle A, angle C is equal to angle F. If the corresponding angles are equal, then AB, the sides, the ratio of the sides also equal. AB by DE equal to BC by EF, BC by EF, and AC by DF, AC by DF. Triangle ABC is similar to triangle DEF. ABC is similar to triangle DEF. This is angle, angle, angle rule. If in two triangles, side of one triangle are proportional to the side of other triangle, then their corresponding angles are equal, and hence the two triangles are similar. Triangle ABC, triangle DEF. AB by BC, AB by AB by DE equal to BC by EF and AC by DF. This is angle A equal to D and angle B is equal to E, angle C equal to F. This is therefore ABC and DF are similar with respect to a side formula. If two angles of triangle are equal to corresponding angles of another triangle, then the two angles are similar. ABC and DF, these two triangles where angle A equal to angle D, angle B equal to angle E, angle C is equal to angle F by angle sum property. Therefore, triangle ABC is similar to triangle DEF. This is angle, angle rule, angle, angle rule. If one angle of a triangle is equal to one side of the other triangle and the sides including these angles are proportional, then the two triangles are similar. Now this is triangle ABC, triangle DEF. In this two triangles, angle A equal to angle D and AB by DE equal to AC by DF. Therefore, angle ABC is similar to angle DEF. The ratio of area of two similar triangles is equal to the ratio of the squares of their corresponding sides. Triangle ABC area and triangle DEF area is equal to the squares of sides AB square and DE square is equal to BC square and EF square is equal to AC square and DF square. If a perpendicular is drawn from the vertex containing the right angle of a right angle triangle to the hypotenuse, then the triangles on each side of the perpendicular are similar to one another and the original triangle. Also, the square of the perpendicular is equal to the product of the lengths of the two parts of the hypotenuse. In triangle ABC, angle B is 90 degrees and BD is perpendicular to AC. This BD is perpendicular to AC. Now then, angle ADB is similar to BDC. ADB is similar to BDC, this triangle. And BD square is equal to AD into DC. Pythagoras theorem: in a right angle triangle, the square of hypotenuse is equal to the sum of the squares of other two sides. So in triangle ABC, angle A equal to 90, AB square plus AC square. AB square plus AC square is equal to BC square. In a triangle, if a square of one side is equal to sum of squares of the other two sides, then the angle opposite to the first side is right angle. In triangle ABC, if AC square equal to AB square plus BC square, where B equal to 90 degrees. This is converse of Pythagoras theorem. Baudian theorem about 800 BC. The diagonals of a rectangular produces itself the same area as produced by its both sides, length and breadth. In rectangular ABCD, area produced by the diagonal AC equal to AC into AC, that is AC square. Area produced by the length is AB into BA, that equal to AB square. And area produced by the breadth BC into CB, that equal to BC square. Hence, AC square equal to 1, that is AB square plus BC square. A sentence which is either true or false but not both is called a simple statement. A statement formed by combining two or more simple sentence statements is called a compound statement. A compound statement of the form if then is called conditional or implication statement. A statement obtained by the modifying the given statement by not is called its negation. Theorem number 1. The basic proportionality theorem, also called Thales theorem. Proposition: if a line is drawn parallel to the one side of a triangle to intersecting the other two sides in the distinct points, then the other two sides are divided in the same ratio. This is called theorem number 1, the basic proportionality theorem or Thales theorem. And given a angle ABC in which D is parallel to BC and D is intersects at AB. D is intersects at AB. In D and AC in E. AC is in E. So to prove AD by DB is equal to AE by EC. So construction: join BE, CD, this is BE and CD, and draw perpendicular, that is EF to AB, and DG is to perpendicular to AC. Proof: in EAD, triangle EAD and triangle EDB, here as EF is perpendicular to AB, therefore EAP is height for both of triangles EAD and EDB. Area of EAD equal to 1 by 2 into base into height. 1 by 2 into base is AD and height is EF. So area of the ADB equal to 1 by 2 into base into height. That equal to 1 by 2 into dB into EF. Therefore, EAD by EDB is equal to 1 by 2 AD EF by 1 by 2 DG dB EF. EF cancelled, 1 by 2 cancelled, AD by dB మిగిలిపోయింది. Similarly, area of EAD by ECD is equal to AE by EC. Similar, and triangle DBE, triangle ECD are on the same base DE and between the same parallel lines DA and BC. We have area of triangle DBE is equal to area of ECD, hence 1 equal to 2, then AD by DB equal to AE by EC.